Where did we stop? The last class? Spectrum we started. What did we cover in that? Huh? New student. Welcome. relatively soft in spectrum. We had defined the electromagnetic spectrum. So, क्या किया? Did we do deviation? Deviation distortion that is created. Unity is cumulative also. Oh. I think we had completed this part. The second part we had start. We have to start with electromagnetic spectrum. Okay. So the electromagnetic spectrum. What is spectrum first of all? It is in order. All the arrangement is done either in increasing order of wavelength or frequency, decreasing order of frequency. So that is spectrum. Now, what is the electromagnetic spectrum? So we are already familiar about the spectrum of white light. What is the spectrum of white light? How many colors it has? 7 colors. So spectrum of white light it has 8 colors. Spectrum of white light. You are familiar with this. As you go from left to right, what happens to the wavelength? What happens to the wavelength as you go from left to right? It increases, right? So what is the wavelength of violet color? 4,000 angstrom or 400 nanometers. So we have two new students. What's your name? Ashwik. Ashwik. Okay, and you? Moksha. 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 Very good. क्या बात है? न तो नाम ही मोक्ष रख लिया है। ठीक है। So violet color, what is the wavelength? 400 nanometers or 4,000 angstrom. And this is 800 nanometers or 8,000 angstrom. So as you go from violet color to red color, the wavelength is increasing. What about frequencies? Decreases. Okay. So the ordered arrangement of all the wavelengths, all the colors present in the white light is the spectrum of white light. Okay. Where is this white light coming from? It's coming from sun, right? The white light is coming from sun. But when the rays coming from sun is fed to a device called spectrometer and analyzed, right? So this is the visible spectrum. This is called visible spectrum. Means it is visible to human eye. But there are other radiations or other rays that are invisible. But that can be detected electrically. Okay? Where it can be detected? In the device called spectrometer. Okay? So when the sun rays are fed to spectrometer, So when the sun radiates, or the light coming from sun or the radiation coming from sun is analyzed with the help of a spectrometer, the visible spectrum forms a very small part. Okay. So it consists of Vibgyor. It's a very small part, right? To the right of red color, you have infrared. Okay. There are certain more radiation to the right of red color, which means their wavelength is bigger than the wavelength of red color. Also, if you go to the right of infrared, you have what is called as microwave. Right? To the right of microwave, you have radio wave. Okay. Okay. So we have, apart from the visible colors, we also have some bigger wavelengths present in the sun ray, and they are named after the red. The first wavelength is categorized as infrared. Now, this is a range of wavelength. It is not just unique single wavelength. So there are infrared rays of shorter wavelength and longer wavelength. There is a band of infrared rays. Understood? Then you have microwaves, whose wavelength is even bigger than infrared. Then you have radio waves. They are the rays with largest wavelength. Okay, longest wavelength are radio waves. Where is it present? In sunlight. Okay, but these are not visible to our eyes. It is not visible. So this is forming invisible spectrum. When I say invisible, it is invisible to human. Maybe there are certain animals, okay, who might detect infrared, or also on the other side, on the left side, left of violet, you have what is called as ultraviolet. UV rays or ultraviolet. Or UV rays. To its left, you have X-rays. To its left, you have gamma rays. So as you go towards left, the wavelength is reducing and the frequency is increasing. Higher the frequency, higher the energy carried by the radiation. Okay, so which ray has maximum energy? Gamma rays, right? So all the radiations to the left of the visible spectrum carry much higher energy as you go from here to here. Okay, and as you go towards right, the energy reduces. That's why in mobile communication we are using microwaves. So it is safe, right? Radio waves we are using for broadcasting radio signals, okay, or television, etc. That is in this side. All the signals. So when we are watching TV, the signal reaching our house is safe actually. Okay, so that's what it is. So this is also invisible. Okay, so you cannot detect it through human eye. The human eye detects only this small part. So the entire range of the wavelengths coming out of sun is called electromagnetic spectrum. Full. Why electromagnetic spectrum? Because these are light rays are electromagnetic radiation. Why it is called electromagnetic radiation? See, if this is light ray, let us say it is propagating from left to right. So you have these two planes. So the electric field is oscillating in one plane. What is this plane? Let's say this is X, this is Y, and this is Z thing. Actually, this is not in the scope. I'll just tell you why it is called electromagnetic waves. Because it has electric field vibrating in YZ plane. And the magnetic field is vibrating in which plane? XY plane. Is that clear? So this is now your magnetic field. Okay. Now, what is the direction of propagation of light wave? So electric field is perpendicular to both. And this is magnetic field. So E is perpendicular to V and E is also perpendicular to B. Okay. So they are all mutually perpendicular to each other. So since this electric field is vibrating perpendicular to the direction of propagation of wave, what conference is going on there? Are you guys free to check? Nameless characters. What am I explaining here? The transverse nature of electromagnetic wave. When do we say the wave is transverse? When the particles of the medium oscillate perpendicular to the motion of wave. But here there are no particles because light radiation travels through space. In space there is no particle. So what is oscillating in this case? It is the electric and magnetic field. So it's an advanced concept to be studied more in higher standard. But this is what I've explained to you. That is why we say light has a transverse nature. Because electric and magnetic field, they are generating each other. Changing electric field produces magnetic field, and changing magnetic field produces electric field. So they are producing each other. Okay, and they travel together. And so let's say this is the light ray coming towards you. So this is how it is. The electric and magnetic field are oscillating perpendicular to it, and it is in 360 degree. So for everywhere you have electric field and a corresponding magnetic field. So it's surrounding it. It's the full cylindrical envelope approaching towards you. Yes. So this is Maxwell's right hand. Let's not go there. Okay. So you have when we reach there, we'll discuss. So what I'm trying to explain here is the velocity vector or the propagation of the light wave or electromagnetic wave is towards you. So what is oscillating? The electric field and the magnetic field. And it is throughout the space. And for every electric field, you have a corresponding magnetic field. You understand? So visualize full electric field and a corresponding magnetic field everywhere around the propagation of light. So what is traveling towards you is the energy field. Electric and magnetic field are energy field. So the electromagnetic waves carry the energy associated with it in the form of electric and magnetic field. That's why they don't require particle. That's why they are able to travel in space. Because they are self-generating. Electric field produces magnetic field and the magnetic field produces electric field.
I heard that light travels in the form of photons.
Yes,
Photons are different.
that's a different. So where are you watching light at? It depends on the experiment. Okay? When you see it as the continuous motion, then it is wave. So it acts as wave and particle, depending upon what situation.
According to physics, that cannot be, but it also.
No. According to physics, it is both. It has dual nature, according to physics. But to understand the other nature, it's like right now the skin, it looks like one single surface. But when you look at a macroscopic level, at a where's the attendance? At a macroscopic level, it is just one piece. I am one piece. But I am made up of atoms. At what scale I am at atom? I am atomic at a microscopic scale. So it is the scale at which you are studying light. So the context is different. Yes. तो जाना फिर उठ के मतलब बैठा हुआ है ऐसे क्या नहीं समझा ये समझने की जरूरत नहीं है दिस आई एम एक्सप्लेनिंग ओनली ट्रांसवर्स नेचर ट्रांसवर्स क्या होता है ट्रांसवर्स वेव पता है तुम्हें क्या होता है ऐसा ऐसा मतलब दो टाइप का वेव होता है ना लॉन्जिट्यूडनल एंड ट्रांसवर्स लॉन्जिट्यूडनल कौन सा वेव है साउंड वेव तो साउंड वेव कैसे प्रोपेगेट कर रहा है मैं बात कर रहा हूं तुम्हारे तक साउंड एनर्जी पहुंच रही है कैसे पहुंच रही है जो पार्टिकल्स ऑफ द एयर पार्टिकल्स है जो मीडियम के उसको वो ऐसे डिस्टर्ब कर रहा है पैरेलली वेव ऐसे जा रहा है और पार्टिकल्स ऑफ द मीडियम का वाइब्रेशन कैसे है पैरेलल so the energy is transferred from one air molecule to the other till it reaches your eardrums and finally the air molecules inside your ear they are hitting the eardrum और फिर वो mechanical energy is converted into electrical signal that goes to your brain that's how you cognize you recognize okay तो यहाँ पे this is called longitudinal when the propagation and the particles of the medium oscillate parallel that is longitudinal दूसरा क्या होता है water wave कैसे जा रहा है is the particle carrying the air molecule here near me is it reaching your ear no it is transferring the energy through collision you can say okay लेकिन water में क्या होता है the wave propagation अभी तुमने यहाँ पे एक still water है यहाँ पे एक stone drop किया तो wave disturbance कैसे travel करता है ऐसे you see that the wave is ripples are spreading out that is only disturbance it's the water molecule is not traveling water molecule is not traveling the water molecule is undergoing this motion up and down so because the medium is elastic what's your name come here Yadav come sit here fast you get up go back fast oh wait these shameless characters will never improve maybe good no sit here you have to also maintain the discipline in the class sit there and don't talk Pritush you are the epicenter of all the disturbance you told me once sir I am not but I am witnessing you और ये शरीफ बदमाश है अखिलेश तो यहाँ क्या पिक्चर देखना है वेयर इज योर नोटबुक so more details about this you'll study in higher standard so basically I was explaining just the transverse nature of light and it travels in it can travel without a medium so उसमें particle तो होता नहीं है तो transverse किस वजह से due to oscillations of the energy field associated with it that's it is that clear
Yeah, I will party. I'll leave here. Leave here. Other.
okay so is what is electromagnetic spectrum understood this entire range of wavelengths form electromagnetic spectrum अब उसमें तुम्हें क्या करना है you have to basically memorize what are the wavelengths what are the wavelengths here so wavelength for violet color is 400 nanometer yes and this is 800 nanometer ठीक है Then what about the wavelengths on this side? It will be less than 400. तो यहाँ पे less than 400 होगा और यहाँ आते आते क्या हो जाएगा? How much is this? Give me your book. Give me your book. ये इसमें उल्टा बना दो. You have a textbook? हाँ. Okay. So this is 10 nano. This is 10 nano. This becomes 10 raised to minus 2. And this is even less. Okay. And here, this becomes 10 raised to 6. 10 raised to 9. And greater than. So try to memorize this. I have difficulty remembering this, but just keep this range of wavelength in mind, right? So look at the wavelength. So ultraviolet wavelength range is from 10 nanometer to 400 nanometer. Sometimes a question may come. There will be a wavelength value given to you, and you'll be asked to identify this ray falls in what category of electromagnetic spectrum. I mean, name the ray. So you'll identify if the wavelength is within this range, it has to be ultraviolet ray. Okay, such kind of questions come. So it's just a memory test. So this is what it is. And how do you calculate the frequency range? So this formula, C is equal to F lambda. So F will be equal to C by lambda. Using this formula, you can find out frequency. Okay, so try to memorize only wavelength, otherwise it gets very confusing. And calculate the frequency. Okay, is that clear? Okay, so everybody find a way for yourself to memorize wavelength. I don't have a trick, like chemistry teachers have so many tricks to memorize. So ये कैसे करना है वो you have to work your way out. Okay, is that clear now? Okay. Now, from all these rays, we have to now learn about the properties of these rays. So there are certain common properties across all the rays. Okay, so let's discuss those properties. So common properties of EM waves. So waves, rays, or radiation, everything is synonym. Everything is synonym. Okay. So common properties of electromagnetic waves. So these are all, everything is Who is chatting now? Any doubt? So what is this? All of these are electromagnetic rays. Like gamma ray is one type of electromagnetic ray or electromagnetic wave or electromagnetic radiation. They are referred to by different terms, but they all mean the same thing. Okay. Now, all of these rays have some common properties. What is the common property? All EM waves travel in vacuum or space with same velocity. Okay, so the speed of light or the speed of gamma ray or the speed of microwave, radio wave, they all travel with this speed, 3 into 10 raised to 8. Okay. Next. So what is the type of light waves? Light wave is also EM waves or electromagnetic waves that you have studied already. So are the others. Okay. So light obeys reflection, laws of reflection and refraction. So does all the others. Although they are not visible, but they will also undergo the same laws. Okay. All EM waves obey laws of reflection and refraction, just like light waves. Okay? All EM waves have transverse function. All EM waves have transverse nature. Okay? All EM waves have transverse nature due to electric and magnetic fields vibrating perpendicular to the direction of propagation, as I explained. Okay? But those details are not expected from you, just know that. If you write EM waves have transverse nature, it is understood that E and B are oscillating perpendicular to the direction of propagation of wave. So have you written it down or can I erase it? Erase it? Or, so like I said, EM waves do not require a material medium for its propagation. Can propagate without any material medium. Meaning it can propagate in vacuum or space. Can it propagate through material medium? It is not a mandatory requirement like sound wave or waves in string. Sound wave cannot travel in vacuum. It requires air. So sound wave can travel in all solid, liquid and gas. Isn't it? But for light, such a condition is not there. Light can travel through space. That's how sunlight reaches up. The distance traveled through the medium is only when the light travels through the Earth's atmosphere, which is about 300-400 kilometers above the surface of Earth. Rest of the distance is the lakhs of kilometers. It travels through space only. So it can also travel through transparent medium. It can travel through space, but it can also travel through transparent medium like glass, water. Okay. So any transparent medium, EM wave can travel through. Right. Or it is not deflected by electric or magnetic field. Not deflected by electric or magnetic field. Meaning, if the light wave is traveling, okay, let's say it is traveling like this, and you apply across it electric field or magnetic field, the light wave will not be deflected. It will continue in the same path. So what is deflected? A charged particle. That means it doesn't have any charge. The light wave is not consisting of any charged particle. That's why it is not deflected. Okay. So these are the common properties of all the electromagnetic waves, right? Then there is a table given in your book which summarizes the property of electromagnetic waves. Okay, in your notes, this is given. But go through the book, I would advise. But it is the same thing reproduced here. So you can go through each line, right? So let's take, for example, gamma rays. So what you have to understand here is in what frequency or wavelength range it is falling. So in the book, what is given is the wavelength range. Out here, they have given you the frequency range. So like I said, remember it through wavelength. So you can just fill in the wavelength range here. Just fill in the wavelength range or see your textbook. That is better. In Selena, the range is given. Okay. So what is gamma ray? First of all, it is invisible rays. Come on page 112. 112 in your volume. So frequency range mentioned is 10 raised to 21 to 10 raised to 19. So it is decreasing. As you travel from left to right, the frequency is decreasing. So who discovered gamma rays? Marie Curie and Becquerel. So they were conducting experiments on radioactivity, or they discovered radioactivity, right? So we're not going into details of it. So basically, who discovered gamma rays? Becquerel and Curie. Now, what is the source of gamma rays? Gamma rays are emitted by radioactive substances. What are radioactive substances? Things like radium, then uranium, right? So all those things are radioactive substances. Why they are called radioactive substances? Because they emit radioactive rays, which is alpha, beta, and gamma rays. Alpha, beta you'll study in the last chapter. Okay. Okay. And it is also found in cosmic rays. Now, what is cosmic rays? See, here we are studying the spectrum of sun. Now, sun is not the only luminous body in the universe. There are so many luminous bodies, stars, etc. So all of them are emitting electromagnetic radiation. So the cosmos or the universe is full of such radiation. We are analyzing only sun rays right now. So all such radiations are called cosmic rays, apart from sun. Sun is also part of cosmos. Okay. So sun ray also has gamma rays. So what are the source of gamma rays? Sun rays, other cosmic rays, and radioactive substances. Is that clear? So sun ray is also cosmic ray. Okay. How do we detect gamma rays? So there are gamma ray detectors, right? So in laboratory, now this table में जितना भी rays है, all these rays, one is it is available naturally inside sun, but we can also reproduce such rays in laboratory. Like for treatment of cancer, etc. When we expose the patient with gamma rays to kill cancerous cells, so those gamma rays are very of moderate energy. Otherwise, it will annihilate the patient completely. Okay. So these are moderate gamma rays just to cure cancerous cells, right? So we can reproduce all of them. So we need to know whether it is gamma ray or not. So there are certain gamma ray detectors. So mostly, whenever gamma ray falls on a zinc sulfide screen, ZNS, it creates a fluorescent spot. Okay, so those are gamma ray detector. There are gamma ray sensor or detector. Okay, with the help of that we can do it. Also, gamma rays can penetrate through very thick metal sheets. Metal sheets as thick as 30 centimeter, like almost a foot, 12 inches, right? It can penetrate through a 30 centimeter thick metal sheet. That powerful it is. And couple of meters of concrete walls. It can penetrate through that. Okay. So that powerful it is. So this is method of detection. What are the properties? These are most energetic electromagnetic radiation can penetrate through human body. Means it will only leave a hole. Okay. So that's what it is. Uses kill cancer cells and to check welding. So when you do welding in industries, there may be some minute holes left or cracks. Okay. So with the help of gamma rays, we can actually detect if there any crack left. Okay. So all those things. So likewise for every ray, how it is produced or where it is found, the source, the method of detection, and its use. All of it is given. And also their discovery. So like X-ray, for X-ray, the frequency range is given. Then who discovered it? Röntgen. How it is produced? Whenever fast stream of fast moving electrons is stopped by any heavy metal target, then it produces X-ray. Okay. So then how do you detect it? You can detect it by photographic plate wrapped in a black paper or kept in a wooden box. Okay. X-ray, to everybody has seen. What is that X-ray film? That is the photographic plate. Okay, on which when X-ray is exposed, it generates the image. So how the image is created? So let's say a hand X-ray is being taken. So the plate is kept here below the hand, and X-ray is thrown over the hand. Right? It is directed. So the bones will not allow the X-ray to pass. The rest of the X-ray is reaching the plate. So the film is exposed and some of it is unexposed. Now when the film or the photographic plate is developed, so then wherever it did not reach remains white, others is blackened. So you have different shades of gray. This is how the X-ray image is created. Okay. So likewise you can read through the others. Is that clear? How to make sense of it? Out of it? So there may be things that you may not understand also. Right? So these are advanced class topics. For example, if you take microwave, so who discovered is Hertz? Who discovered microwaves? Hertz. What is the source of microwave? Now, electromagnetic waves can be produced in laboratory by accelerated charged particle. Now, accelerated charged particle is nothing but when the charged particle is accelerated like this. Okay, so this then becomes an oscillatory circuit. Whenever the charged particle makes a motion like this, it will leave an electromagnetic wave in the atmosphere. Okay, this is the theory. So those circuits are called oscillatory circuits. So these are advanced topics. Right now, you just take it as a term. Okay, so there are certain oscillatory electrical circuit which will produce microwave. It's also called Kilstrom tube. In your book, it might be given as Kilstrom tube. Is it given? Kilstrom tube or just oscillatory circuit? Is it given Kilstrom tube? Textbook. Or just oscillatory circuit? There are you. Yeah. What is given? Just electronic. So they are not giving you the details. So you have to mark it up. There may be 1 mark question, not too much. This chapter is a small weightage. Okay? Because too much of memorizing, these are just thrown at you right now. Okay? So just be familiar with all this. Mostly the question is asked on uses. So what are the uses? Just go through the uses of all the rays and you can ask me in case you need further explanation. Just complete this table right now. Which table? This table. No, just go through it and ask me if you don't understand any of this. Unit field. Is there advanced topic? Yeah. Frame the question. Put it as a understand what you're trying Right now, you are building is very process. Welding. So two metal plates are welded together. So outside you are seeing it is welded properly. But there may be some fine portion where you missed welding. Then you expose it to gamma ray, it will be detected on the other side. That means the welding is not proper. Book में सब दिया होता है. So it's an advanced series, right? Now you're not taking Polaroid camera में क्या होता है? Like when you step out in bright sunny day, okay, you will not be able to open your eyes completely. But when you put the Polaroid glass, so what it does, देखो, Polaroid glass में क्या करता है? There is a concept of polarization. ठीक है? Let's say this is the light coming towards you. Now the visual sensation is because of the electric field. You are the question. The visual sensation is due to the electric field. Now I said electric field is this electric field is 360 degrees. Everywhere there is electric field. Okay. So on a bright sunny day, these electric field will contribute to the brightness. So polarized glass में क्या होता है? It blocks all the other lights. It blocks all the other electric field. It only let the light pass in one direction. तो सिर्फ ये दो आता है, बाकी सब कट ऑफ हो जाता है. So the brightness reduces drastically. It filters all the other. You get it? So that is called optical access. Now that is advanced topic, very detailed. Okay? So that is, this is called polarized. This is what happens. So it cuts off the other electric fields. So you now have a very moderate light topic. Okay? It reduces the brightness by 50%. If you want to reduce further, so you will use two polarites. Okay? In lab you can do that, but in a glass you can't have two glasses. Okay? So you can control it even further. Advanced topics. Any further doubts in the application part of it? Uses and application. Follow. Okay, now, so you don't have to bother about the uses of these. Okay, now we have to study in detail properties of ultraviolet and infrared rays only. Only two rays. You have to study the uses of only ultraviolet and infrared rays. Okay, so now you can go to questions will be asked on only infrared and ultraviolet rays in exam. The full electromagnetic wave spectrum is given. You can read it once from your book. Okay. But you have to study these two in more detail. Which and which? Ultraviolet, infrared, and visible. Okay. So that is given on page number 109. This table. Just memorize this table. Page 109. So just go through all the properties of ultraviolet radiation, visible radiation. You don't have this. हाँ तो ये पढ़ो बैठ के. Read the properties of ultraviolet rays, visible rays, and infrared rays. 142. So I think it is quite self-explanatory. Three, and you can study these from your textbook only. They're given in more detail. Okay? So basically, what you have to study the method of production, how they are produced, what are their uses, okay? And how they can be detected. These three things: production, detection, and use. So, like infrared, what is the use? In your TV remotes, right? And physicians also use it for therapy. Like if you have a sore muscle, right? The light rays that are given to you is basically infrared rays. So they are basically they heat the surface wherever infrared falls. When sunlight is falling on our skin, we feel the warmth. The warmth is due to the presence of infrared rays inside sun. Is that clear? White light is not hot. The infrared inside it is hot. Is that clear? So all hot bodies emit infrared rays. So you can generate infrared rays. When you heat any substance, you are producing actually infrared rays. Is that clear? So likewise, so this is the first time this thing is being introduced. So you might be little lost. Read it again and again, then it becomes like a story. Okay? Not very difficult. Just because it has come for the first time. थोड़ा अलग लगेगा. ठीक है? And the way to understand is try to read and ask question. ये पूरा रट्टा है chemistry जैसा. ठीक है? क्योंकि unless you see it in action, it is a lot of imagination. Okay? So we'll see it. We'll do that in the next meeting. We still have 2 minutes. In the meantime, anybody has any question can ask. You can come here, ask what question you had. Explain here. You have to articulate the question. You have to frame the question correct. Then only, okay. What is it? It is a spring. It is a spring.
It's like such. You need to accomplish the
Rolling in Let's say this velocity, horizontal velocity, and this will be time of revolution. And so what is the time? What is the velocity here? This is the velocity. Okay, let's call this as V horizontal ये क्या है? ये vertical लोग इसको क्या बोलते हैं?
मैडम इनको केमिस्ट्री का वॉल्यूम चाहिए
ये side का, ये horizontal, ये parallel ले लो तो उसको perpendicular ले लो. This is
मेरे को भी मैथ्स का सेकंड वॉल्यूम
ठीक है? तो perpendicular velocity से क्या हो रहा है? ये आएगा तुमको T is equal to 2 pi r distance upon time period. नहीं वही time period is the time between two threads. divided by v perpendicular. ठीक है? तो ये जो distance traveled है ये कितना है? Horizontal distance समझो x है. This will be E parallel into T, which is equal to E parallel into 2 pi r divided by v perpendicular. ये है. वही है वही.
So this is what I derived from that. I was just thinking experimentally, what would